Donald Kosman. I'm a professor at ETH Zurich in the Department of Computer Science. And what we do is we develop new technology to answer big questions. And we do that by applying big data technologies. My personal definition of big data is to automate experience. What I mean with that is that based on previous experience as data, try to avoid the same mistake twice. If you've done something before, don't do it again. If Adam stole the apple, the first time is okay, the second time is not okay, according to big data. Maybe a more complex example is in medicine, where a doctor is confronted with a rare disease and hasn't seen it before in his own personal experience, but the disease has happened before somewhere else. And so the doctor has access to that experience, to the data of that previous incident, and can learn from that, from the therapy, and maybe adjust the therapy and learn and improve the therapy. So big data is always then very attractive if systems are very complex, too complex to understand, but they have rules under which they behave, and you can kind of, the past is a good predictor of the future. Big data is bad if the past is not necessarily a good predictor of the future, which is always then when humans are involved, like financial markets, where people believe that the past is a predictor of the future, but then they will change their behavior. Crowdsourcing is a way to achieve and to get data. And that is very successfully applied in many scenarios. So we are part of crowdsourcing every day by using search engines like Google or Bing. We participate, and essentially what we do is we give data, we give experience to Google or Microsoft so that they improve their search engine. So crowdsourcing, and there are many forms of crowdsourcing. This is one that is typically called a passive crowdsourcing. Then there are more active crowdsourcing where we actively engage into studies and we give our input. But in all of these cases, the human input is data, is evidence, and the inference that follows from that and the gaining of the experience is just as done as if it were not human input. My belief is that data is a resource and it's owned, and my data is owned by me, your data is owned by you, and so we both should take advantage of whatever is done by this resource, and we should both control what is done by the resource. Now, the other aspect of that is the society has some interest and some right, in some sense, to use our data to do things that are in the benefit of greater society. And one example is cancer. I'm not a doctor, but at the moment, or a scientist, but at the moment there's a belief that the key to solving cancer lies in big data by gathering a lot of incidents of cancer and then drawing conclusions from that. And in some sense, we as individuals, healthy and not healthy, have somewhat an obligation to contribute to these bigger efforts to cure cancer, which then will benefit ourselves as well.
My name is Kevin Shavinsky. I'm an assistant professor at the ETH Zurich, and I work on the origin and formation of supermassive black holes, how they affect the galaxies they live in. And I also have a second life in citizen science, which is the direct engagement of the public in scientific research. So Featurezoo is an online citizen science project where we've enlisted the help of the public to help us classify galaxies. And this started in 2007 when I was a graduate student in Oxford, and I was trying to find a particular kind of galaxy, and for that I needed to classify 1 million galaxies or so by their shape. After a week of working all day long from morning till evening, I classified about 50,000 and I was done. Now, I got really incredible science out of it for my PhD thesis, but I realized, the remaining 950,000 also really ought to be classified so we can get a better understanding of how the universe works and how galaxies evolve. So one evening in the pub with a colleague of mine, Chris Lintott, we came up with the idea, hey, let's put those pictures of those galaxies on the internet and see if maybe members of the public would be willing to help us. Now, we did that, we built a website, we put the images there, and we totally underestimated the amount of interest that this would garner. So within a few hours of the project going live, it was knocked out because a server physically melted because of the interest that the site had generated. So many people wanted to go classify galaxies, explore the universe, and help science that we were completely overloaded, because within a few hours of launch, we were doing what I did in a whole week all by myself, several times an hour. Humans are natural pattern recognition machines. Evolution has honed the human brain to recognize patterns. It's taken computer scientists more than a decade to teach a computer to tell one human face from another. And any child, the moment they open their eyes, can perform the same feat without breaking a sweat. And so we're really, really good at pattern recognition. So what we've done with the help of Featurezoo and the wider Zooniverse is we've built the world's largest distributed pattern recognition supercomputer by linking up by now 1 million human brains to go do pattern recognition tasks in science, which is going to help us tackle the big data flood that we're going to face in the future. As data sets get larger and larger, we're going to build telescopes that are going to take terabytes of data every night that is time sensitive and needs to be analyzed. Other fields of science are going to generate similar sized data sets, and we kind of already have them. And so in the future, citizen science is going to be essential if we're going to analyze the data we're going to collect. And so what I envision in the future is that we're going to have a sort of cyborg melding of the human brains and the machine brains. So we're going to try and understand how to optimally combine machine learning neural nets with humans, and how to decide who should look at which data first. And if the machine says this, send it to a human to verify, or the other way around. How do we do this? We don't really know yet. But if we're going to tackle the big data challenges of the future, we better learn how to.